Okay, so here's symbols for assemblies and special applications. There's another standard called ASME AED-1. It provides dimensioning and tolerance requirements for aircraft and advanced engineering applications. Okay, and they'll use this aggregated datum feature symbol, which has to do with what is the aggregate datum between mating parts. And then there's the elliptical fillet, which is EP, followed by the ellipse size. And then there's a parabolic fillet, PA, which gives you 2 dimensions and how many degrees of from 0 radians does it go. Okay, there are old symbols, and it did change fairly recently in 2018 and 2019. So a lot of the symbols that I'm used to using throughout my career, I got into this business in 1991. So some of these symbols will still be on old drawings, and some companies run on an older standard because they don't want to up-rev all their drawings. So here's some past practices. You used to have a concentricity and symmetry symbols, which they got rid of in 2018. They were concentricity was very commonly used. It has been removed because you can do similar controls using the position geometric control and circular runout. So they decided to remove it from the standard. Then there's symmetry, which I guess in 82 looked like the position symbol. But the symmetry is almost impossible to hold because even if you have a loose tolerance, to have something absolutely symmetrical is very difficult to do. And it wasn't used very often, so they eliminated symmetry. So the more recent drawings are going to have the 3 lines, 1 longer line straddled by 2 shorter lines. And then you have RFS. It used to have a symbol that you had a circle S if it was regardless of feature size. Now it's implied it's regardless without of feature size unless there is a M or an L symbol on your drawing. So it's getting a little more efficient, getting rid of some symbols that were kind of not needed. Okay, so existing drawings and models may comply with previous standards and they're okay as long as that drawing says interpret towards that revision year. So that's why it's important that you know that the current standard is ASME 14.5 2018. So that's why we're testing for that. But prior standards 2009 and 1994, you're likely to see 2009 drawings around common. And if it's a company that's had a mature product's been around a long time, probably a lot that are still in the 1994 format. I worked for Aero Metals, and we were working with drawings that went back to 1952 that haven't changed. So there was quite a gamut of different symbology usages. So we would have to go up and research what era those symbols were denoting. Okay, so that's why it's important to understand the past processes. And symbols updated or discontinued without replacement. Okay, past practices. Here's some more. Here's with the frames. So from 1994 to 2009, it's assumed the RFS modifier is assumed but allowed to be shown for position tolerances. And maximum material condition modifiers could be applied to datum references. Now in 1982, you required a modifier for position tolerance. So it could be S, L, or M, and it could be applied to the datums. On other types of frames, it's implied that it's RFS. Okay, in 1973, it's getting pretty far back. You're using the abbreviation DIA for a diameter, and it came actually after the number. instead of preceding it. And the optional location of the datums could be on the opposite end of the frame. So that's changed. They're always on the tail end of the frame, right hand side of it, or the end of it. Okay. In summary, that gets us to the last slide here. So we're almost done. In summary, in this lesson, you learned to identify and apply general dimensioning and tolerancing symbols, gained a clear understanding of their purpose and applications in engineering drawings. You also explored how to use basic dimensions in both annotated models and traditional drawings, ensuring precise communication of design requirements. Additionally, you developed the skills needed to construct and complete a feature control frame following the correct order of segments to accurately define geometric tolerances. By mastering these concepts, you were able to create clear, standardized technical drawings that effectively convey design intent to manufacturers and quality control teams. In conclusion, by the end of this lesson, you were able to identify and apply general dimensioning symbols and explain their general applications, identify and apply tolerancing symbols and explain their general applications, identify and apply basic dimensions in annotated models and drawings, and complete a feature control frame using the correct order of segments in the frame. And this concludes the lecture for Unit 2, and we will catch you on the next one.